And if you have any questions, I've got the chat on the side, or you can unmute at any time and ask a question. And if you have personal or specific questions, I guess stay till the end of class and we can talk one-on-one about what you need to do for your math requirements this semester, or like maybe what you're concerned about in this class. Okay. Oh, no, I can figure this out. So the syllabus is posted to Canvas. I'm going to share it with you. I've had a handful of classes today trying to find the correct syllabus for us. We are Math 1-43 ready, set. Okay. For Math 1, section 43, which is mathematical reasoning, it's a 3-unit class. So the class does give you units, and it does require a general education requirement. However, it will not prepare you for another math class. It's its own fun math topics. Okay, for fall 21, here's the syllabus. My name is Cassandra Walker, or Cassie, Professor Walker, Professor, anything that helps you to get my attention, I'll respond. There's my email, the class number. If you need to add the class, you'll need this number. We meet Tuesday, Thursday at 3. And I will record the meeting, post it hopefully that night, and post it to YouTube and then copy it to Canvas the next day. The class meetings are linked to Canvas, but here's the link. If you don't have, maybe like, here's the link to the class meeting. Here's the meeting ID. I have office hour Monday, Wednesday from 1 to 2:30, or we could set up an appointment. I can meet pretty much anytime in office hour. There's the link to office hour and its meeting ID. As a side note, both of these meetings are open. They're always open, so you can sign in anytime, but I will not be at the meeting until like the scheduled class time or office hour time or appointment time. There is no prerequisite for the class. Yeah, for Math 1, no prereq. No prereq. It satisfies area B4 of general education, and it will contain a writing component. So for exams, which will be on Canvas, you will type a response in an essay box. If your response is a sentence, please write a full sentence. You don't have to do a whole paragraph or anything, just make it, complete sentences. Let's go. As we're talking about working on problems, you don't have to show your work. You could just put the answer. But sometimes people who show work and make a mistake will get a little more credit because I can see what went wrong and where the mistake comes from. All right, so for course materials, you don't need to buy a book. Let's come back out to class. So here's the book. It's not huge, but from this book, we're only doing a couple of sections. So we're probably only going to cover like this much of the book. And from those sections, I'm making all of my own homework and test problems. I'm not using these problems. So I really don't think this is necessary. if you really want to buy a book, it's by Tannenbaum called Modern Mathematics. And it's where I picked my topics. I don't think you'll need a book, and I will create assignments in Canvas, so you don't need to buy anything for the class. No access codes or textbooks. Back to the syllabus. So we talked about the book being optional. I really don't think you need to buy any materials for our course. And maybe if anything, use Google or YouTube to understand, or see me in office hour and we can practice. So for the catalog description, this class is for students whose major does not include specific mathematics requirements. Like if you don't have to take a certain stats class, or if you don't have to move on to other math classes, you can take this class to fulfill a general education requirement. But again, this class does not prepare you to take another math class. It's its own kind of fun stuff, fun topics presented by me. Okay, let's see. We want to practice using mathematics, blah, 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 use math vocabulary, focus on using, onto course structure. So the whole course will be on Canvas. We're going to use quiz, the quizzes to create homeworks and assignments, or homeworks and exams. So it'll say homework quiz or exam quiz. They'll be sorted into different groups, like the homework group or the exam group. And we will cover 3 chapters or 3 topics. We start with chapter 15 and then take a test on graphs, charts, and numbers. So we sort data, and then we switch to chapter 16. It's kind of related, but it's a new topic. It's statistics kind of stuff, probability, odds, expectations, and we take a test on chapter 16. And then we do something completely different called graph theory, which is in chapter 5, and it's the mathematics of getting around. And then we take that test, and there's no cumulative final, just 3 exams. So there will be weekly homework, but you have no homework this week. I'll post the first homework next week on Tuesday. And then it will be due the following week. So we'll probably do 3 homeworks for every topic, 3 homeworks, then exam, 3 more homeworks and exam, last 3 homeworks, last exam. Exams will be during weeks 6, 11, and 16. And none of them are cumulative. So for class, attendance is not part of your grade. I do think it helps keep up with material if you can be at each meeting, but I don't make it a requirement. I do record our meetings. If anyone's at a meeting and sees that I've forgotten to record, just remind me, it happens. But I should be able to record meetings and post them to Canvas in the modules. Like I said, I will make homework for you. Homework has multiple choice answers, and it's 28% of your grade. Exams have an essay answer response. Again, you can just write your solution or write your response, but some people have been able to upload a picture of their work or send a PDF of their problems, and I can grade that too. So either way works for me. And then once you have a score at the end of the semester, I will assign a letter grade using this scale. The last part is services provided by the school. There is services for students with disabilities. So if you think you require testing accommodations, contact SSWD. Maybe you can ask questions. You can ask me questions about that after class or privately. There is also the Student Health and Counseling Services in the WELL for any healthcare, eye care, counseling. You can find that at no cost from the WELL. Usually you can get those free services at school. And the last one is CARES for assistance with food and housing and other financial challenges. Contact CARE for support. That's the end of the syllabus. And before we talk about our class, I have places where you can find help with math, just in case I'm not available. Okay, I think that's pretty good. So there's the math lab, and I'll share information about each of these this week. There's peer assisted learning, which is called PAL. And there's a program called Commit to Study. So I'll either post an announcement or send an email about these places where you can find free tutoring from students, from tutors, from groups that have like teachers and tutors and all sorts of people in them. They're available to you to help you through the semester. But of course, you can always talk to me and I can help you with homework or even exams. If you need help on a test, we can meet an office hour and I can help explain what's going on. I don't mind. Park. Oh yeah, cool. Park. P-A-R-C. I think I have information about that one too. So I'll look up all of these, get back to you this week or next week, but as soon as I can, so you can get help. Get that. Okay. Anything we need to talk about? Let me think through some questions I've gotten in the past. So some people ask about exams. Okay, so it's pretty open, I would say. You will always have a week to work through an exam. Even if it's like finals week and you missed a test, I'll give you an extension and I'll unlock the assignment so you can try to get some points for anything that you've missed. I just think it's good to stay on schedule and not let things pile up. So I would turn it in on due date, but I don't mind extending due dates if you need extra time. Okay, I did not put time limits, so there will be no time limit once you start the test, just this week to get it done, but actually doing a test doesn't have a time limit. I have it set to unlimited attempts. And if you do a few attempts, I would choose the highest or best response. So like your highest score is your score. So I really want you to pass the class. The point is just to make sure we get enough practice during the semester on all of the topics. And you can work with me or other students, but I feel that your response should be in your own words. Please don't copy paste. Just write your own full sentence or submit your own solution. But it's okay to ask for help. All right, let's do some notes. Or any questions before we do notes? Okay, here. Someone basically said that if they submit a scan or PDF of their responses, does that mean you have to fill in the essay little boxes? No, I would just go in, and if I have work from you and that space is missing, I'll just use that work and put a score on that problem. So just as long as you turn in something for the assignment, whether it's on campus or it's like through email, I will grade it. All right. Any other questions? Okay. So really, I've picked topics from the book that are kind of my favorite. And we don't have to do too many notes today, but I want to introduce chapter 15 and do a few examples. And that's the plan. Okay, so in chapter 15, we organize data where we work with sets. And I just had a thought come to mind. So if you do turn in a picture of your work, it's a plus because I can see maybe how you got through the problem and give you credit for maybe like partial credit if you made a mistake. But it means that that's kind of your one attempt, unless you want to turn it in again later, turn in a new picture PDF later that week. Then I guess from those I could choose the highest score. I just don't want to have too many copies of things to look through and grade. So try to just turn it in one time if you do it that way. Okay. Just put it as sets. Okay. A set is a collection of objects that we call elements. We use capital U to denote the universal set. Okay, and which is the set of all elements under consideration. So it's your whole universe. Set of all elements under consideration. Okay, a subset is a set. Let's call it a name. So usually capital letters will be for sets, and if the elements are letters, they're going to be lowercase. And we were talking about subsets. So we're going to say that capital A is a subset of capital U, the universal set. So this is the math version, and then we'll go through examples, I think, and pictures that will help explain what this says. So let's do this. The set A is a subset of U. Capital U. If every element in A is also an element in U, the universe, the universal set. I think at this point a picture would help. So the universal set is usually drawn as a square, in your Venn diagram. We start with a universe drawn like this and labeled somewhere. Let's label it over here. Subsets are going to be circles inside of the universal set. So we'll put this circle here and label it A. And we're going to put a few elements in our example. We'll have numbers 1 and 2. Okay, so let's talk about writing a set. By the way, so the universe is the full square space. The subset A is the set that contains 1. Outside of the set A are the elements 2 and 3. So 1, 2, and 3 are elements in the space. And 1 is an element in subset A. We're going to practice all of that. First of all, we write sets. Let's back up and say, sets start and end with curly brackets. All right, let's go into an example. So here is the first example with the universal set, capital U, which contains 1 through 6. And A is a subset of U, capital A. it contains. So the set containment is to start with a curly bracket with the elements inside. We're going to have 3, 4, 5. Close the set with a curly bracket. I just want to say you don't need to repeat elements. So if you have 3, 3 as a repeat, just 1 3 is needed. And they don't have to be in order. It could be 4, 3, 5, just as long as each element is there inside your set. Okay, set B is the set that contains 1, 3, 4. Let's do 1, 3, 6. And we're just doing a Venn diagram for this one. So draw a picture starting with the universe, which is a big square. Label it. A is a subset of U. Every element in A is also in U. Like you've got 3 here and it's there. 4 is in A, it's also in U. 5 is here in A, 5 is here in U. So yeah, it's a subset inside of that set. But also, I won't ever try to trick you. If I say it's a subset, it will be a subset. You don't have to stop and check. B is this set inside of U. It contains 1, 3, 6. It contains 3, 4, 5. So I want to spot common elements when I fill in the rest of the picture. So 3 is in both. So it's in A and B, which means it goes in the overlap. 5 is also in both sets. Here. Oh, never mind. I was like seeing something else. That's it. 3 is the only element common. So we're going to make it. Okay. A contains 4 and 5, but 4 and 5 are not in B. They need to be over on this side. Outside of the set B. B contains 1, 3, and 6. 1, there's 3, there's 6. Universe contains 1, 2, so let's put 2. 3, 4, 5, 6. All right, there's our set. Okay, there are 3 special subsets that we want to cover in this class. It's union, intersection, and complement. All right, we want to start with 2 sets. Let A and B be sets. Then A is a swoop. It's like a symbol that looks like a U without the part on the side, so it looks like this. A union B. Let's write as A union B. So this symbol is when you kind of think of it's an A or B. So the set is all X in the universe. So X in U. There's a bar. The bar means such that. So it's like such that. Okay, X is in A or X is in B. Close the set with a bracket. The next one we're going to do is the union. Oh no, we did the intersection of sets. So we're still going to use those two sets A and B. It's just a new symbol to check out. So for intersection, all right, so it's been a lot of talking today, so trying to make it through. Let's see the notes. A intersect B. So that symbol is for intersection. It's an A and B. So you start your set with the curly bracket. Your elements are from the universe. Your elements are called like any X value in the universe U, such that X is in A and X is in B. It has to be in both. Whereas for the union, the one we just did, it can be in one set or the other set or both, but this one has to be in both of the sets at the same time. Okay, last one. Is the complement of sets. So it has a superscript C. So when you see a capital C, it's representing complement. So you take your set, let's use the set A, and write A, and up here, superscript, capital C. I mean, it can be a lowercase or capital, but I will put a capital. So it's read as the complement of A. But you can think of it as everything that is not in A. So you start your set with the curly bracket. You're finding elements, call them X, in the universe, U, such such that X is not in A. And then you close your set. Cool. So those were the subsets I wanted to cover. And now we just do examples for the rest of class. If you have questions at any time, or if you see any mistakes, let me know. I'll try to keep an eye on the chat. So we're starting with the first universal set containing 1 through 5. Capital U. The whole space, or your whole universe, has 1, 2, 3. So those are your elements. You have the subset A, which contains 4 and 5. And another subset B, it contains 1. Okay. We're going to practice the Venn diagram, the union, intersection, and complement. Okay. Oh yeah, let's go back. Picture. So your Venn diagram. We start with a big universe, which is shaped this label somewhere. Here. It really doesn't matter. Just as long as we're just trying to be clear and draw a nice picture. Okay, A is a subset, B is a subset. We'll have them overlap just in case they share common elements, but I don't think they do. So next, I would want to fill in that shared space where A overlaps with B. That's the intersection. So this part right here is A intersect B. But this time we're going to have A intersect B. You start your set, and what's inside? 4, 5. This has 1, nothing in common. So there's nothing inside of your set. So you could write empty brackets, or like you can have a parentheses between empty brackets. But most people like to write empty set. So it's a set that contains no elements. The union of A and, or let's say A unioned with B. That's our next goal. I'm going to start with the curly bracket. So you take the elements from A, put them together with the element from B, and they don't have to be in order. 1, close your set. Okay, A complement and then B complement. Okay, so A complement, you can think of this as like not but we want to write it as a set. So if you were doing homework or an exam, you would have it written as the set that starts with a curly bracket. Everything that's not in A, so everything except for 4 and 5, which would be 1, 2, 3. This is your full space, so you're not using 4 or 5, you just have these guys. B complement, so we need all of the numbers except for 1, which would be 2, 3, 4, 5. Start your set with the bracket, put your elements, separate by comma, close your set with bracket. Also back to this part here. When you have an intersection that is empty and it's called the empty set, there is another symbol. It's this 0 slashed that way. So this symbol, or writing empty set, or empty brackets, it means those are for when you don't have any elements in your set. Okay, so again, empty set is this. That contains. All right, let's stick with elements that are numbers, but the universe is going to have some negative numbers. It doesn't really matter, it's just a symbol for us. But we're going to do this example with capital U equal to the set with we're going to do negative second, negative 7, negative 3, negative 2, 0, and 5. I'm going to change it up with the subsets. So this time, the first subset is capital E. And it contains negative 3, 0, and 5. Your other set is capital F. We're going to put negative 7 and 0. And then I would ask questions. So the Venn diagram helps solve a problem. I think it helps to see what's going on. But I probably will ask for either the union, intersection, or complement in an assignment. But I think it helps to start with the Venn diagram. Your full space here is capital U. Labeled somewhere on the side. Let's overlap your subsets just in case, which I see already they have a common element. Put that in the overlapping part. Gotta label as E. Okay, first thing I would do is find common elements, like 0 is in both sets. Let's put it here and here. And this. And that's it. E needs negative 3 and 5 inside the set E, but outside of set F. needs -7 and 0. We've got 0. We need -7, which is not in set E, so it needs to be outside of that circle. Don't forget any other elements. We took care of this one and that one. -2 needs to go outside of both of the subsets, but inside of your universe. Got 0 and 5, and we're good with the picture. Okay, let's come to this, just this side. E. Let's do E complement. So this C means the complement of E, or the set that's like not E. But you want your answer to be a set with curly brackets, elements outside of E, which are -2 and -7. Or you can come over here and cover -3, 0, and 5. Which leaves these ones. Close your set with a curly bracket. We'll stick with complements. Find the complement of F. So all of the elements that are not in F, which means don't use -7 or 0, but you can use -3, 5, and -2. And then you close up the set. Let's find the union of E and F. So union is for or. Well, I'm just going to say it, or. So it's an E, or it's an F, or it's in both. So we take this set, put it with that set, and have -3, 5, 0, and -7. So I'm going to shade the union of the sets. All of this. Curly bracket, put your elements. Close your set with another bracket. And then the last part is the intersection, which is that part right there where they overlap. So E intersect F is the set that contains 0. Alrighty, let's switch it up just a little bit, and we're going to use elements that are letters. So if you've noticed, we've got letters as sets, but they're capital letters. So if your elements are letters, they're going to be lowercase. And I'll probably make that clear when I create a problem. We have the set U, and it contains this one, W, X, Y, Z. The subset capital A. is the set that contains, so put a bracket. It contains, I just put W. And B contains, let's put XC. Close that set and we'll draw a Venn diagram. Okay, so get started with your universal set. We'll put A, and just in case they share elements, we'll have B overlap with A. I mean, it doesn't have to be perfect, but still. Okay, I would check the intersection first. Are there any common elements? There's just W here, there's no W's there. So this is going to be empty. We put W in set A, but outside of B. B contains X and Z, but A does not. So you need X and Z in that set, but outside of this one. Don't forget about Y. There's W, X, Y, somewhere like here, and then Z. Okay, let's get A intersect B. Okay, so it's got to be an A and it has to be in B, but we've already kind of looked at the picture. There's nothing in both sets, so I would write empty set. Some people like the symbol like this. I just think that looks like 0, and this is very clear. We want to get the union. For union, it means or. So you're in A, or you're in B, or you're in both. So one, the other, or both. Which means it's this set together with that set. You need W, X, and Z inside of curly brackets. A complement is everything that is not in A. So if you have a picture, you can cover up that set and use Y, X, and Z. And then B complement. So it's outside of the set B. So if you're not in set B, then it's elements W and Y. Okay. I've got one more example. Depending on the time, we'll do another and call it good for today. So still working with letters. We have a new universe. It's got A, B, C, D, E, F, G. Start your set, you put in your elements. And then you close the set. Let's have our subsets as capital E, capital F. Okay. Start the set. E has A, C, lowercase e. So lowercase a, lowercase c, little a, little c, little e, close your set. And your other subset is F. And F I have A, B, E. That seems cool. So we're going to have set containment, elements A and B. Let's put G. So usually I would give this kind of information and then ask a question. Kinds of questions would be about union or intersection or complement, but I think a picture helps. So we'll go over here and do the Venn diagram. Whole universe has subsets E and F. Maybe they have common elements. So we'll draw them like this. Now check for common elements. There's A in both of the sets. E is in both of your sets. That's it. So they need to be in the intersection. Finish this one. A, C, E. Now we've got set F contains A, B, E, G. And then check just in case for anything that got missed. A, B, C, you need D, E, F, lowercase f, and then G. Let's find the union of these sets. So if you have E union F, it looks like this, and it means it's an E or F. So that set together with that set, no repeats, just okay. List C, A, E, and B, G. And close that. So it doesn't need to be in alphabetical order, and you don't want to repeat any elements, and you need them inside of curly brackets. E complement is E with a superscript C. And if it's the set not E, so not these elements, but you do need B, G, D, F. And let's talk about the complement of F, which is F superscript C, and it's everything that's not in that set F. So cover up your set over, let me see if I can do this over here, and then what's left is C, C, D, F. All right, let's see, we're a little after 4 and we've got like 15 minutes left. So I think we need to do like one more example, but then we can finish. I feel like I've had more questions about sets that contain letters, so we're going to keep working on problems like that. So our universe, U, will have LMNOP. So you start your set. You put in your elements, lowercase letters for elements. And then you close the set with a bracket. Let's have capital A be the set that contains M. Capital B contains put some shared elements like LMO. Okay, so I think it helps to draw a picture of everything that's going on. A overlap with B, labeled. So M and O are common to both. It needs to go here. We've taken care of that set already. It's all filled in. Go over to set B. You need L, M, and O. And then outside of those sets, you have other elements. Got this, we need N and P to sit somewhere over on the side. Okay, so A intersect B is first. So it's an A and B. All right, M and O are in both of the sets. If you want A union B, it's an A or B. Okay, so that's it, or both, which is M-O, M-O-L, LMO. Which happens to be the set B, but we're just going to write it out. Let's get the complement of A and the complement of B. So this is like not A. As a set, it is everything except for M and O, which means you need N, P, and L. Last one. Here, B complement. So if you're not in B, then it's the set of everything else outside of B, which is N and P. And double check that one. So if you hide that set, got these elements left over. All right, so we're gonna head out a little early. That's it for today. If you have questions or concerns, just hang out after